All right, I wanted to write something else. So go. All right, so we're going to talk about circles and parabolas today. Now, the reason that we call these conic sections, I'm going to grab a picture here, because we can think of all of these shapes as coming from a slice of a cone. So we have some cones here, and if we slice the cone with a plane, and we slice it so it goes only through one side of the cone, we get a parabola. If we slice it parallel to the base of the cone, we get a circle. If we slice it at an angle, we get an ellipse. And if we slice through both sides of the cone, we get what we call a hyperbola. So one reason that we do this with the conic sections is it's always nice in math when you can think of these things that seem very different as just different aspects of one thing. So all these curves are just different aspects of a cone. So that's why we call them conic sections. And conic sections turn out to be very important kinds of curves. Students often don't believe me, but this year in my Calc 3 class, I remember we were doing something, we started working with conic sections again, and I said, remember when we talked about this, we were talking about which direction the axis goes and all that kind of thing. And I said, remember we talked about that in pre-calc? And the student said, well, we didn't think we'd have to remember it. So yeah, they do end up being kind of important. All right, so for today, we're going to talk about circles and parabolas. So we're thinking about them as conic sections, but the definition, the way that we're going to do the math with them is another way of thinking about them, and we call that the locus definition. So I'm going to give the locus definition of these things, and we'll talk about how that leads to the equations that we're going to work with. So a circle. A circle is the locus. A locus is just a collection of points. And I'll add points, the locus of points. That's a little bit, that's redundant, saying a locus of points. A locus is a slight, but I think it makes it a little more clear. The locus of points in a plane that are equidistant from a fixed point, and we're going to call that point HK, and that point is the center, and that's our definition. The locus of points in a plane that are equidistant from a given point called the center. Now this idea of distance is going to be important for all of our conic sections. All the conic sections have something to do with distances from something else. And for a circle, what do we call that distance? These points are all the same distance from the center. That's the radius. So the distance is the radius. Now, a reminder, the distance formula. Distance d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So the distance between the 2 points x1, y1 and x2, y2. And the distance formula is really, it's the Pythagorean theorem. Distance formula and the Pythagorean theorem are the same thing. So what we do is we apply this is our definition of a circle. We apply this distance formula to this information that we have in our definition, and we come up with what we call the standard equation. Of a circle. And hopefully this is familiar if you worked with circles in the past. So our equation, x minus h squared plus y minus k squared equals r squared. And our center is the point hk, and the radius is r. So all we're doing is applying the distance formula to our circle, squaring both sides. So the distance is the radius. We square both sides. X and y is the point on the circle, and hk is the center. So the distance from a point on the circle to the center is the radius. That's all we're saying there. All right. Questions there? All right, so let's look at a couple of examples of problems that you'll see with circles. We'll get to my. I always like when we get to this point in the semester because there's something, another old friend, not trigonometry yet, but another old friend reappears, and we're always excited when we see our old friends in math. All right, so we want to find, I'm going to say, when I say the equation, I'm talking about the standard equation. Find the equation, I'm just going to write EQN, of the circle with center -1, -4, and it goes through 5, 7. So we know the center and we know a point that it goes through. Well, the center gives us what for our equation? That gives us our h and our k. So we have that. So we know our equation is going to look like x plus 1 squared plus y plus 4 squared equals r squared. Well, what does this 5, 7 give us? It's a point on the circle. So in terms of this equation, what is that? That's our x and y. So we can just plug those in and find the radius. The other way we could think of it is to find the radius, we need to find the distance between 5, 7 and -1, -4. Really, what this way of thinking about it that we wrote out here is the same. So I'm going to plug that in. So 5 plus 1 squared, 6 squared is 36. 7 plus 4 is 11 squared is 121. And that equals r squared. So r squared is 157. We don't need r for our equation. So our equation is going to be x plus 1 squared plus y plus 4 squared equals 157. The radius would be square root of 157. All right, questions there? All right, this next one I don't want to go all the way through. I just want to talk about how the procedure we would use to solve this next one. All right, so let's say the endpoints of a diameter are 3, 4 and -5, -6. We want to find the equation of the circle. Excuse me. All right. We need 2 pieces of information. We need the center and the radius. Well, how can we find those things? Well, this is the endpoints of a diameter. How is the center related to the endpoints of the diameter? Yeah? It's in the middle. So our center is the midpoint. Do we remember how to find the midpoint of a segment? Just some of the expressions on our faces. Midpoint is the average of the coordinates. x1 plus x2 divided by 2. That's our x coordinate. y1 plus y2 divided by 2 is our y coordinate. So we find the average of the x coordinates, average of the y coordinates. So that's going to give us our midpoint. So we can find the center by finding the midpoint of the diameter. How are we going to find the radius? Half the distance, the radius, is half the distance between the endpoints. So we use a distance formula to find the distance between the endpoints, divide that by 2, and you get the radius. That reminds me of, you get a bonus today. You know what the difference between a radius and a diameter is, right? A radius. All right, so we're not going to go through the calculations, but this would be our setup. All right, this next one, this is the nice one, where we all get very excited. All right, we want to find the equation of the circle (9x squared plus 9y squared plus 54x minus 36y plus 17 equals 0. So for now, you're just going to have to take my word for it that this is a circle. As we go further in the chapter, we will learn how to tell when an equation like this is a circle, an ellipse, a parabola, etc. But we'll just have to take my word for it for this time. So I'll tell you this is a circle. And I'm going to, well, this is, why don't we say instead of the equation, we want to find, so this is an equation. We want to find the center and the radius. So we need to write this in standard form. Any ideas about what we're going to do here? It's kind of like, more than kind of like, what we did when we wanted to find the vertex of a parabola. When we did chapter 2, when we talked about parabolas in terms of quadratic functions. What do we do there to get it in vertex form? Some of us use negative b over 2a. That won't work here. What was the other technique? Did we forget chapter 2 already? Complete the square. But we have an x squared and a y squared. So we complete the square twice. So we get to complete the square twice. Notice I said we get to, not we have to. We get to. This is a good day. All right, so what I will do, what I would recommend, we're going to gather up all the x's and y's together. So I'm going to write it as 9x squared plus 54x plus 9y squared minus 36y. And I'm going to put the 17 on the other side of the equation because we need our r squared over here. All right, so we're going to group the x's. We're going to complete the square there, and we're going to complete the square there. So before we complete the square, what do we need to do here? We don't want that leading coefficient on the x squared, so we need to factor that out. So I'm going to write this as 9 x squared plus 6x plus 9 y squared minus 4y equals negative 17. And now let's complete the square. We divide this by 2 and square it. So we add 9. And I'm going to, for this, since I have an equal sign here, I'm going to add the same thing to both sides. So what have I actually added here? 81, right, because that 9 is distributed. So I have to add an 81 here. And I divide this by 2. I get negative 2, square that, and I get a plus 4. And I have to remember that 9 is distributed to the 4. So we add a 36 to the other side. Now we have a perfect square, a couple of perfect squares. 9 x plus 3 squared plus 9 y minus 2 squared equals, this turns out nice, this is 100. We're almost there. Standard equation, the x squared and the y squared don't have numbers in front of them, so we're going to divide everything by 9. And I'm just going to write that as 100/9. So our center, now we have a nice standard form, negative 3, 2. And the radius is the square root of 100/9, 10/3. Isn't that nice? When you go further, when you talk about three-dimensional shapes, to find the vertex of a parabola, the center of a sphere, you have an x and a y and a z, so you complete the square 3 times. And just, again, the negative b over 2a thing doesn't work here. That only works for parabolas. All right, questions there? Okay, let's talk about parabolas next. Parabolas. So let me grab a picture of a parabola as a conic section. We'll do the same thing that we did for circles. Whoops, that's not what I wanted. I wanted this. We'll give the locus definition, and then we'll write the equations that the locus definition tells us. So parabola as a conic section, we get that when we slice through just one side of the cone. We get a nice parabola. All right, so we're going to define a parabola as the locus of points in the plane that are equidistant. There's that equidistant again. From a given line called the directrix, and a given point, the focus. So you may have heard, if you took physics, physical science, you may have talked about focuses of lenses or mirrors, that kind of thing. So you might have heard of the term focus before. We're going to work with that idea in just a slightly different context. And we're going to say the axis, we called it the axis or the axis of symmetry before, goes through the focus and the vertex perpendicular to the directrix. And we'll draw a picture in just a second. So what this is saying is, I'm going to draw a nice parabola here. So here's a parabola. The focus is always inside the parabola. So this is our focus. The directrix is outside the parabola. So here our directrix is going to be a line down here. So that's our given line, the directrix. Isn't directrix a nice word? I like the word directrix. It's nice. And the axis, here's our vertex. The axis goes through the focus, through the vertex, perpendicular to the directrix. So there's our axis. And what this thing about the equidistant is telling us is that if I have a point, any point on the parabola, if I draw a segment from the focus to that point and draw a segment perpendicular to the directrix, oops, let me just move that right at the last second. There we go. And our distance, to get our distance, we're going perpendicular to the directrix. If I call this distance 1 and this distance 2, the distance from the focus to the point and the directrix to the point, what we're saying is that D1 always equals D2. For any point on the parabola, those two distances are always the same. If we draw those segments, the lengths of those segments are always the same. So what we do to come up with our equation that we're going to work with, we're not going to go through the process, just want to tell you that's where our equation comes from, is you write, using the distance formula, the distance from the focus to the parabola, the distance from the parabola to the line, you rearrange that a little bit, and you get a nice equation for a parabola. Now, one benefit of working with this definition of the equation is we can now work with horizontal parabolas. Before, we only worked with vertical parabolas. With this definition, we can work with horizontal parabolas. So our parabolas don't have to be functions. And it's the same is true for our other shapes. We can work with vertical, horizontal. They don't necessarily have to be functions, and we have a nice way to deal with them. All right, so what I'm going to do is write our equations for parabolas, like we did for our circle, that come from this definition. All right, so for a vertical parabola, our equation is x minus h squared equals 4p y minus k. We have this extra thing of p here, and I'm going to draw a picture and talk about what that means. So here's my parabola. Here's my vertex, hk. Here's my focus. The distance from the focus to the vertex is p. And my directrix would be down here. So this is my directrix. The distance from the vertex to the directrix is p. So that's what the p-value tells us. So let's put some more information here. The vertex of this parabola is at the point hk. The focus, because it's a vertical parabola, the focus is either going to be up from the vertex if the parabola opens up, or down. So we're going to go up or down from the vertex. So we have to add or subtract from the y portion. So our focus is going to be at the point h, k plus p. So we're moving vertically to get to the focus. The directrix. We're also moving down if it's opening up, or up if it opens down to get to the directrix. So we're going vertically from the vertex. So our directrix is the line y equals k minus p. Our axis goes through our focus and our directrix. That's going to be the vertical line, x equals h. It has to go through these points. If p is positive, our parabola opens up. And if p is negative, our parabola opens down. And the way that we can tell right away that our parabola is vertical from our equation is the x part is squared. So it's like y equals x squared, the parabola that we're used to. And we can if we needed to graph this parabola, we get two additional points. At 2 times the absolute value of p, left and right from the focus. So if I went straight left here, I would get a point on the parabola. If I went straight right here, I would get a point on the parabola. And this distance is 2 times the absolute value of p. This distance is 2 times the absolute value of p. So p tells us something about how wide the parabola is also. It tells us how far the vertex is from the focus and the directrix. It tells us about how wide our parabola is. And if this is 2p here, and this is 2p here, altogether, what is that distance? 4p. Oh my goodness. 4p. So 4p is telling us how wide the parabola is. So we get all this information just from looking at the standard form of our equation of a parabola. And we'll talk about a special thing about the focus right at the very end. I want to have a nice demonstration of how to draw a parabola. All right, questions here? Okay, I'm going to do the same thing for a horizontal parabola. And then we'll do some examples. How are you going to guess that the horizontal parabola is going to be different from the vertical parabola? Any ideas? Yeah? Sophie? It's going to be horizontal instead of vertical? Yeah? That's one piece. Basically what we do is switch the information about the x's and y's. We're going to go left and right instead of up and down. So it's exactly the same idea. We're just moving in a different direction. So let's do that. Horizontal parabola. And we're going to be able to tell that the parabola is horizontal because the y part is squared. So my equation is going to be y minus k, k always stays with the y, squared equals 4p x minus h. And if I draw my parabola, here's my horizontal parabola. There's my vertex at HK. My focus is inside. My directrix is going to be a vertical line now. So my vertex is still at HK. That doesn't change. And we'll see HK a lot this chapter for a lot of different shapes. Our focus. This time we're moving left and right from the vertex to get to the focus. It's still p units. So I need to change the horizontal coordinate. So my focus is going to be h plus p, comma k. My directrix. We're still going left and right, from left or right from our vertex, depending on which direction our parabola opens. So now we're going to have the vertical line, x equals h minus p. The axis is a horizontal line now, and it goes through the vertex and the focus. So that's going to be the line, horizontal line, y equals k. If p is positive, our parabola opens right. And if p is negative, our parabola opens left. And this time we get additional points. Two times the absolute value of p units, up and down from the focus. So we go up, we get a point here, go down, we get a point there. And that distance is to absolute value p. So right at the focus, our parabola is open 4p units wide. All right, questions? So the questions in chapter 9 that have to do with parabolas, that have to do with ellipses, that have to do with hyperbolas, really, we get asked the same question in 3 or 4 different ways. It's really this, you get the same question over and over and over again. Can you go from the equation to the vertex and the focus and the directrix? Can you go from the vertex, the focus, and the directrix to the equation? Can you go from this piece of information to find the vertex, focus, and directrix? So you're just manipulating all of these things over and over and over again. It's really, you get asked the same question with different numbers for the entire chapter 9. All right, so let's look at some parabola examples. All right, we want to find the vertex, the focus, and the directrix of y equals 0.5 x squared. So in chapter 9, the key for these things to get our information is going to be to write it in standard form first. Well, in standard form, either the x squared is by itself or the y squared is by itself. So let's write that. So I'm going to change this to standard form. Divide both sides by 0.5, same thing as multiplying both sides by 2. I get x squared equals 2y. That's my standard form. Well, this is nice. What's our vertex? This is x minus what? 0. Squared plus 2 times y minus 0. So our vertex is at 0, 0. Does it open up or down? We know it's vertical because the x is squared. Oh, yes, it should be an equal sign, Demi. Thank you. We know it's vertical because p is positive. Well, what is p? 4p equals 2. So p equals 1/2. So our focus is 1/2 unit up from the vertex. So our focus is going to be one-half unit up from the vertex. So how do we write 1/2 unit up from 0, 0? 0, comma, 1/2. And the directrix, 1/2 unit down, we get a line. A horizontal line 1/2 unit down from the vertex. So what's that horizontal line going to be? Y equals half a unit down from 0, 0, negative 1/2. And if we drew a little picture, here's our parabola. There's my focus, or my vertex at 0, 0. There's my focus at 0, 1/2. Here's my directrix, y equals negative 1/2. And if I needed to plot this, if I wanted to plot it accurately, I could plot these 2 points directly left and right from the focus. And 2 times 1/2 is 1. So that would be the point 1, 1/2, and negative 1, 1/2. 2 times 1/2 this way, 2 times 1/2 that way. And I would be able to make a pretty accurate graph of that parabola. All right, questions? All right, now we're going to go the other way. Let's say we're going to be given that we want the standard equation. We have a parabola with its vertex, excuse me, with a vertex at 0, 0, and a focus at 0, negative 2. What I suggest for a problem like this is draw a little picture. So here's my vertex at 0, 0, and here's my focus at 0, negative 2. So which direction is that parabola going to open? Down. The focus is always inside, so we know it opens down. So we know it's vertical, and it opens down. So we have those 2 pieces of information right away. Well, this is at 0, 0, and this is at 0, negative 2. So what is this distance? 2. And it opens down, so we know that P equals negative 2. Well, we're all set now. We have x minus 0, or sorry, x minus 0 squared equals 4p, negative 8, y minus 0. And we could write that as x squared equals negative 8y. And there's our equation. If we needed to graph that, we could graph 2 points, 4 units to the right and left the focus. All right, questions there? All right, these next couple, I don't want to go through all the work. I just want to talk about the procedure we would use. What if we wanted to find the vertex, the focus, and the directrix of the parabola x squared minus 2x minus 16y minus 31 equals 0. What are we going to do? Someone said it? We're going to complete the square. Since only x is squared, we only have to do it once here, or we only get to do it once. So what I would do here is write this as x squared minus 2x equals 16y plus 31. Get the x's and y's on different sides. That's our standard equation for a parabola. And then we're going to complete the square. And then I would say, once we complete the square, then we can pick out our information. Because once we have it in standard form, we have our vertex, we know what P is, we know if it's vertical or horizontal. We'll have all that information once we get in standard form. All right, questions there? All right, another one. We'll set this one up. We won't go all the way through the process. What if we want the standard form? So we want the equation of a parabola with a vertical axis the vertex at 0, 0 and goes through -3, -3. Well, we know that it's going to look like, it looks like this. It's vertical, so the x part is squared. The vertex is 0. X squared equals it. The y part of the vertex is 0, so we know it's going to look like this. And we need to solve for y. Well, how are we going to do that? What does this -3, -3 give us? Doesn't that give us an x and y? So to solve this, plug in x, y, solve for p. So we've done that type of problem in a bunch of different contexts at this point this year. So that would be the process for that. We set up a problem exactly like that with a circle. All right, questions there? Okay, last example, and then I want to talk about the reflective properties, what the focus of the parabola tells us. We want the equation. Oh yeah, we're getting back in shape now. We got a little out of shape in chapter 3 because all the notes were so short. We have to build back some endurance. We want the equation of the parabola. With a focus at 1, 2 and directrix x equals 3. So this is how these problems are going to go. They'll give you some combination of piece of information, and you have to get the rest of the information from what you have. So I would suggest here, draw a little picture. All right, here are my axes. Here's my focus at 1, 2. And here's my directrix, x equals 3. Is that vertical or horizontal? X equals 3. So no matter what y is, x equals 3. So that's going to be a vertical line. There's x equals 3. I know it's not to scale. All right, so we have almost everything we need already. So we know that our parabola is going to be horizontal. We know it's going to open left because my vertex is going to have to be like this. So we know it's going to look like that. And if this is at 1, 2, and this is at x equals 3, how do we find the vertex? Well, what do you know about the vertex in relation to the focus and the directrix? Same distance. It's in the middle, right? It's halfway between the focus and the directrix. So what's halfway between the point x equals 1? We know the y-coordinate has to be 2 because the axis has to go through those. So what's halfway between 1 and 3? 2. So the vertex is at the point 2, 2. Halfway between x equals 1 and x equals 3. So there's my vertex at 2, 2. All right, now what's P here? How far is it from 2, 2 to x equals 3? 1. P equals 1. We could also figure out that P equals 1 by remembering that P is half the distance between the focus and the directrix. So we could have figured it out that way. So P equals 1, and it opens left. So I'm going to say P equals -1, since it opens left. And I'm going to say y minus 2 squared, since it's horizontal, equals -4 x minus 2. And if I needed to sketch a graph, I could plot my additional points, 4 units up and 4 units down from the focus. Not 4 units, 2 units. The total width would be 4 units. All right. So all of the questions that are going to be asked are some combination. You'll be given some combination of information, and you need to figure out the other pieces of information. Okay, we good? All right, one thing that's important about the focus of a parabola, the reflective properties. All the conic sections have reflective properties. If this is our focus, light or sound or radio waves or something that comes in parallel to the axis will reflect to the focus. So that's how some telescopes work. They have a parabolic mirror at the bottom of the tube, and that reflects the light from the stars or whatever to the lens. On the side of your house, if you have a dish network dish, it's probably parabolic shaped, and the signal from the satellite bounces off the dish and reflects that to the big thing that sits in the middle there. And it works the other way as well. If we have a light source or a radio wave source or something at the focus, any light or whatever that comes from the focus will be reflected parallel to the axis. So an example of that is this flashlight. The lens inside is parabolic shaped. The bulb is at the focus. So when you turn it on, you get a very narrow beam. Up there, now it's at. So you get a very narrow beam. If I turn this top piece, then the beam gets wider because the bulb is not at the focus anymore. So then the light doesn't go parallel to the axis, it spreads out. So your flashlight has a nice parabolic mirror inside. That's how your flashlights work. Someone said I need to replace, this was a kind of a terrible flashlight, but I think these batteries are 7 years old. All right. Questions? Okay. The homework, I split it into two sections. The first piece is all circles, and the second piece is all parabolas. So you can kind of split how you think about them. All right, there we go. I'll move this in just a second.